Thank you guys for joining us today. I hope you guys had a good conference so far. This space here, I want to welcome you to the 912 Convergence Innovation Lab. You guys may ask what the Innovation Lab is. First, I'll talk to you a little bit about who we are as 912. 912 is our umbrella company, and basically underneath of 912, we set up branded initiatives in emergent technology sectors, some of which we have seen as 5G, advanced manufacturing, hypersonics, trusted microelectronics, and many more. So we're staying very busy. Basically what we are, you guys have heard Mung and Dave Roberts talk earlier in the conference about what a P3 is, a public-private partnership. We as 912 operate P3s. That allows us to have access to state matching grants to leverage the ability to innovate within the state. That allows us to stretch dollars a little bit further and really start to take some of that innovation and put it back into your pockets in terms of budget and capability. So we like to leverage those here in all of our facilities and what we do here. This space here is actually our 912 Convergence Lab, where we will actually start leveraging some of the 5G technology and specifically the CBRS network. So we'll talk about that in a little bit of a second, but just wanted to give you a little bit of background of what these P3s can do. One of our other key characteristics that we really like to employ with the P3s is the ability to de-risk investment from entrepreneurs alike. So it doesn't matter if you're the AT&T corporate giants of the world, all the way down to the mom and pop startups, we can really lower the barriers to entry into the innovation market now, utilizing this model. This is our network lab, so we're focused really on the network connectivity, and really as the Discovery Park District really expands outward, we're going to become the connectivity hub for the entire DPD district. Everything that we can leverage here will leverage the CBRS network, that stands for Citizens Broadband Radio Service. It's a very unique slice of the spectrum. It opened up a few years back. Basically, it is the unlicensed spectrum, so it's fair game at the county level. It's regulated on the county level, and it's sliced into kind of two different slices, right? So you have the commercial slice, and then you have your private access license. So those can actually start to allow you to have innovation test bed capabilities. The real key characteristic for the CBRS network is its ability to lower price and have a new private network. So you don't have to go through some of the major carriers. You can really start to define a new network based on what you need it to do. Like I said, this whole facility and this building, and then eventually the whole Discovery Park District will be built out with CBRS capability through one of our founding partners. That allows a lot of capabilities in terms of innovation because we can start in a lab environment. We can test prototype devices here within our facility, and now we have a new live living lab that we can expand outward from this lab into the whole Discovery Park District and really start full-scale deployment of some of these new prototypes. So it becomes a really unique opportunity to not only test, but then to scale some of these new innovation. One of our other key characteristics that we'll have is one that I find actually most exciting is a 5G gateway. This gateway actually leverages a 4G, 5G, Wi-Fi antennas, so you can actually start to test interoperability of communications network. That test bed also is actually very unique in the fact that it has an embedded Linux platform on it. So you can actually start to design applications on that platform to test over a CBRS network. Our goal with these types of technologies and facilities is that we can kind of create a one-stop shop for any mom and pop all the way up to a corporate giant to have all of the necessary tools here. They don't have to bring or make major investments to come in to want to start to innovate. So with this, you could be somebody that has an IoT device and you want to test an IoT device on a CBRS network. Maybe you're just an application developer that you want to test network congestion algorithms or some sort of application over an edge compute capability. We can start to provide those platforms to where you can literally just walk in and start innovating on day one. Our whole goal here in this whole facility is how can we rapidize or speed up the process of innovation here. We have such close proximity to university and have such good partners in Purdue Research Foundation. We can really leverage that by de-risking that investment, having platforms capable here, and then partnering with key partners in order to speed up that whole innovation process. Some of our other technical advantages here, the Tilson Data Center is actually right adjacent to us behind that back wall. We've looked at capabilities of how we can put edge compute in there. So one of the key characteristics of 5G is this edge compute capability. We want low latency characteristics for some of the use cases. We can now look at how we can leverage that capability on a CBRS network, right? Because 5G is not just one thing. Most people think 5G is just the next generation past 4G. We like to call 5G is actually a basket of technologies that were unavailable in the 4G realm. So now we start talking about software-defined networks, edge compute, this low latency characteristics of being on the edge, start opening doors for AI, ML capabilities and such, and how you can really start to define that. One of the other awesome key characteristics of this lab is we have the ability to remote access back to our Indianapolis facility. Back at that facility, our Indiana 5G zone, we actually have a millimeter wave commercial deployment of both Verizon and AT&T, as well as our own separate deployment of CBRS. So we start to get these remote access capabilities where we can test interoperability between networks. So maybe there's an IoT developer that wants to have an IoT device on our gateway here, and then another IoT device over a millimeter wave back in Indianapolis. We can actually start to define now and test how we can interoperate between different nodes and different cores. So again, it's just another capability that we have to offer that we can bring to Discovery Park District and really leverage our key partners either at the university or through PRF to really use this as an innovation platform. So as we begin to build out further, we'll have more partners come in and we can really start to leverage both our ecosystem personally as 912 as well as the Purdue Research Foundation ecosystem to really start to speed up that deployment of innovation. This is a founding member we have here called the UE group or the User Experience Group. They have about 20 years of experience in the product design world. One of the keys that they really bring to this is how that companies can work and interact with technology. So they're kind of that interaction layer that they can really dive deep into. It was actually a Silicon Valley company based out of California, and we're actually now their first footprint in Indiana, which I think speaks back to that P3 model and the ability for people like Purdue Research Foundation to be an attractor back to Indiana to help grow our ecosystem locally. So I think that's a really important characteristic that we're actually starting to model now is how we can actually leverage the proximity with Purdue University as well as this new innovation capability that we have here, as well as the ability to now bring industry within the ecosystem as well and kind of be a mutually beneficial partnership between all entities. So as you can see, they kind of work with these digital interfaces and the capabilities to interact with. Their goal really is to be able to show how in the next 5 to 8 years people will live, work, and play with technology. As we've seen in the years past and now ever more so moving forward, technology has become integrated into every form of our lives. And really that then leans on the experience portion of this. Everyone has different uses of this technology, and one of the key capabilities is how does that user interface with that technology. This is really what they're specializing in. And to that point, they've really started to notice, the UE group has noticed, the ability to engage with university. The capability that we are establishing here with 912 Convergence Innovation Lab is the ability to reach into the Purdue ecosystem and pull out subject matter experts to begin interfacing with industry was a vital piece that was kind of missing from the natural ecosystem in the United States. So we are becoming one of the first in the nation to be able to bridge that gap between industry and academia through the Purdue Research Foundation and the Discovery Park District. So they will be an anchor tenant here. They'll help kind of the networking side of it, hosting events out of this facility, using a couple unique innovation capabilities of IoT device usage for what they're trying to accomplish.
Another big deal here is the founders of this company, Tony and Kathy Fernandez. Tony is credited with creating the first Netscape interface. And there you have a who's who clientele in the Bay Area, as you can imagine, technology companies, life science companies, entertainment companies, manufacturing companies. And they really wanted to expand their business. Too expensive to expand in Silicon Valley, and any of their team, it's a small team, any of their team gets snapped up by Google and everybody else, all these high-tech product development companies. What happened was their son Ryan, who was a neuroscientist here at Purdue, he graduated unfortunately in COVID years, so he wasn't able to walk across the diploma or stage and get his diploma. But nevertheless, Tony and Kathy, through that 3.5-year experience, kept visiting back and forth, coming to Purdue, and they fell in love with the place, as you can imagine. One of the principal academic areas that would tie to this is in our School of Polytechnic. It's really that user interface, computer design, computer graphics group. So they're really going to be big users of this. Right now, a student to do a project really uses their iPhone to do the user experience thing. What you don't see, or we can open the doors here after the tour, but this will be an observation room. So this is completely soundproof, etc. And this is the observation room. So you've got all kinds of monitors and sensors over here, and you can then be watching how a person engages with the technology to really, see if it's, technology for technology's sake. I'll hold my hand up. I'm an engineer. We can sometimes design the Rube Goldberg, solution to problems versus really looking at the person and their engagement with it. So this is really a unique capability. Our College of Engineering, even our liberal arts theater department is super excited about this, because to set up this room, if you want to set it up as an operating room, guess what? You can wheel in, what looks like a hospital bed and everything else. You can wheel in a couch if you want to test, something in a living room kind of environment. And already we've gotten requests not just to use these two suites, but an aircraft manufacturer, I will leave them unnamed, now that they know they're at Purdue, wants to use our airport to be able to fly in airplanes and do user experience testing on airplanes. And we've got mobility companies that want to set up shop in our Joint Transportation Research Center to do the same kind of thing. So they're very excited. You can't do that in the Bay Area. Very, very, awkward and hard and expensive to do that. So we're really, really, really excited to have these people be part of our ecosystem, because we think it can really add a cool capability, not just for companies, but also opportunities for our students.
My name is Piyush Raj, and I'm from SBA Communication. I lead the SBA Connect division, and this is my colleague David Baker, who is the regional manager for Indiana, and he works within this project very closely and other projects in Indiana. So SBA is a cell tower REIT, a real estate investment trust. We have about 20,000 towers in US, about 500 in Indiana. So we have a big tower portfolio in Indiana. And we are proud to be a part of this project in collaboration with 912 and Purdue Research Foundation, that we have deployed a private network, a first of a kind of a private network in an enterprise settings in a connected community. Let me tell you a little bit about this private network. So this private network runs on CBR spectrum, and it covers all the 5 floors within Convergence with about 15 CBSDs, or radios, that you see on your back right there. And there are like 15 of them in the building. And then we have on the rooftop, we have outdoor radios that cover about a mile radius throughout this campus. So it's pretty much cover a majority of the community within Discovery Park District, and even extends to the campus. So what does it do, and what we want to show you today is the capability of this private network. It is like a secured cellular network, which can do all the things a cellular network can do, except that it is private. And it has all the new applications that you can run. It is upgradable to 5G, and we can actually do voice, you can do data, high-speed data, mobility. And what it offers is for developers, for new application developers who want to come and develop new applications, they can do that on this private network. And that is what we are looking at deploying in several other areas, even in the rural communities that we talked about today, is how the private network can actually open up new opportunities for school students, for telehealth and other applications. So what we want to do with David today is he's going to show some application for private network here, where actually he will basically run a video conferencing session, that he will take that session outside, and you can see the mobility and of this network, which is far better than a Wi-Fi or anybody, because it is LTE, so it is secure and it can do all the mobility. So I'll hand it over to David. Why don't you just start that demo?
Yeah, so what I'm going to do is I have an iPad in my hand, and then I have this laptop hooked up to this TV here. And I've got a Teams call going, and that's probably my arm you see, because this is live. I'm going to turn the sound on so you can hear me, and I'm just going to walk outside. Both of these devices are hooked up to our CBRS network right now live. So I'm going to, let me do that. I've got to make sure this is working the way it should. That's me.
And
I'll move around here. And just test. I'm going to get away because it's going to sound loud. I'm going to go this way. I'm just going to kind of look where just let you know, like I said, I've got this iPad in my hand, and I'm mobile, and hopefully I've got it in a good angle so you can see where I'm going.
Keep going, David. You're still not going.
What was that? I'm sorry, what was that?
Keep going.
Okay. In your front, I'll be running your way, but you want to go live. And walking out the front door here.
So you have the CBRS AP in the front door there also. So after this, the next one is at the front entrance.
Walking out to the front. small atrium here with tables and chairs, with fans, all kinds of slower, and not making anybody sick. But not 5-0. Just connected to all of you folks, and you can walk back in the building now. Actually, I'll walk around here in both places area.
And David, you are outside now or you're inside? Inside.
No, I'm inside.
Okay.
I'm inside. I'm on the car workplace. I was outside a minute ago. I don't know if you guys can see that in the car workplace here. Just walking around. Just kind of
Yeah, David, you just need to fix your camera a bit. Yeah.
left and right.
Yeah.
What's that?
Yeah, no, that's fine now. Now it's much better.
Okay. All right, well, I'll come walk back into the building, or back into our lab area. But basically what we're just trying to do is just, demonstrate that, we have a mobile device for both. I'm going to move here, sorry.
Oh, you're back.
I'm back. I'm going to turn this off so I don't get a bunch of feedback. But basically what that was to demonstrate, it's basically just to demonstrate, like I said, the laptop, I had a Teams meeting call on this laptop and on that iPad, and both of those are on the CBRS network right now live. And so it just demonstrates that we can hold as Piyush mentioned, the CBRS network does everything a cellular network will do, and that's just to demonstrate a couple of devices. We have coverage throughout the building. There are AP access points on all floors. This is a 5-story building. So in the building, you're totally covered. On outside, it just really depends on where you are. It's really good if you go down State Street, and if you get out anywhere within about a mile or so. Just because we only have antennas on this building, so if you go into campus right now, getting into a lot of residences there, it gets a little spotty. But other than that, and we can fix that by adding as we need to go. But this was just our test case to get this up and running.
So one of the things about CBRS is obviously there are 3 things. One is the propagation. It covers a lot more than a Wi-Fi can do. And the second is the mobility. And the third is the consistency of the bandwidth, which is where the Wi-Fi gets challenging, is how to keep that bandwidth consistent. So looking at, like in this building, for example, most of the places we get around, I will say, between 50 to 100 Mbps because of the density of access points, the radios we have. So in order to cover the same amount with Wi-Fi, you will need 4 or 5 times more access points. And then when you go outdoor, it even is 10 to 12x. And the reason is that in Wi-Fi, FCC has set a limit for the power, like the actual propagation of power, which is only 1 watt compared to CBRS, which is 50 watt, which is 50 times more. So that allows you to cover a lot more with the CBRS. And then the last thing is that there is an upgrade path to 5G. So all these APs will be upgraded, software upgradable to 5G. So the architecture is there. We have our edge sitting right at the Tilson data center behind, where most of the local breakout is, most of the processing is happening there. And now you can actually do a software upgrade to 5G, then this can actually go 5 times more. So going back to the question about what is the FCC? FCC or the broadband is looking at, federal is looking at 100 Mbps down and 20 Mbps up. That can be easily achievable with CBRS. It's just that the density will be, you have to just densify the network. And also, that's where our tower infrastructure come into play, because the height of the tower, the height of the site, particularly in the rural areas, matters a lot. So that also helps when you're deploying a network and trying to meet those speeds. So we think that the middle mile can be fiber, but the last mile, which is where the challenge is, can be wireless easily. And wireless is evolving, and with 5G, this is going to get better. If you see around here, you have these devices with antennas, you have a push-to-talk phone, you have all the iPhones. So what the capability that we want to bring it to this building is that you can actually bring your phone, and with the newer phones, you have two SIMs. You have one is called the eSIM, the other is the physical SIM that you can actually, you put it in your device. So the new devices, actually you can scan a QR code, and you can actually get your eSIM activated on private network. So, but you still can have your carrier SIM, and you can work with your carrier. So as you walk out of this area, you can go back to your carrier connectivity. That's something going to happen in next 1 year or so. You will have that capability. So another application for CBRS is, I think we talked a little bit about the IoT. I think everybody talked about IoT today. And as you have more and more IoT devices, you need more of the latency and bandwidth. So one of the applications we talked about today was IoT. And what we are seeing is that CBRS is becoming a great connectivity platform for IoT, just because of, obviously, the capacity, the latency. Because as you start getting more and more IoT devices, already, although we say that we require very narrow bandwidth, but when you have hundreds of these devices, imagine if this building is all become a smart building, then you have hundreds or thousands of devices. For that, a platform like CBRS is great because it can support all that capacity. We are still using GAA. So the difference is when you're inside the building, and if you pretty much have the entire 150 megahertz, because with PAL, if you're not using any PAL license, then all of that goes to GA, which helps inside the building. So that's what we're using now, right now here.